Hi everyone, welcome back to Geeks for Geeks. So today we are going to solve a problem which is named as middle of a linked list. Okay, so let's quickly have a look on the problem statement. So our problem says that given the head of the linked list and we have to find out the middle of the linked list, right? So it's given in the example. So as we can see that, for example, the middle of 1, 2, 3, 4, 5. So this is the linked list which is being given to us. What is the middle value? So 3 is the middle value, right? So we have to return 3 here. And if there are two middle nodes, so this can be the case when we have even number of linked list nodes. So we have to return the second middle. So for example, if 1, 2, 3, 4, 5, 6. So this is my second linked list. It has even number of nodes, right? So what is the answer of this? So we have to return the second middle one. So what is the first middle one here? So 3 is the first middle node, and what is the second middle node? So 4 is the second middle node, right? So we have to return 4 in that case. So let's quickly have a look on the example one. So it's given that 1, 2, 3, 4, 5. So what is the middle value? So middle value is 3, right? So we will have to return 3 from here. So in this example one, return 3, right? Now let's talk about the example 2. So in example 2 we are given 2, 4, 6, 7, 5, 1. So number of nodes, how many number of nodes are there? So there are 6 nodes. So which means that we have even number of nodes present in my linked list. So what does our problem statement says? That problem says that we have to return the middle, but we have to return the second middle, right? We don't have to return the first middle. So what is the second middle here? So second middle here is like 7. So we will have to return 7 here. That's why output given us to is 7. So now, okay, so what can be the brute force approach to solve this problem? So the first thing that comes into our mind is that we can find out what is the size of my linked list, right? So how we can find the size? So we will just try to find out. So we will just try to run a while loop till my like not getting my null value. So it means that there is some node present. So what I will do is I will point that current node to my next node. Sorry. Okay, so what can be the naive approach to solve this problem, right? So the first naive approach that comes into our mind is that we can find out what is the total length of my linked list, and what we can do in that to find the middle one. For example, like if n is the size of my linked list, so to find out the middle one, then I can just go to the n by 2th node and I can just return that node. So this is the first naive approach. So for example, like this is my like linked list, this is total size is n. So how can I find out the middle one? So middle one will be the n by 2. So let's say n by 2 comes up here. So this is n by 2 and this is n by 2, right? So what can I do is, so the first thing is that I have to find out the total length of my linked list. After that I have to reach the n by 2th node from the starting to find out the middle one, right? So this is the naive approach. What is the time complexity here? So the time complexity would be big O of n. But here you have to run two while loops. The first one is to find out the length, and the second one is to find out the n by 2th node from the starting, right? But in interview there will be some follow-up question, right? So in interview there will be a follow-up question on this. So the interviewer will be asked, so the follow-up question will be like, can you solve this by using only one while loop or like one for loop, right? So yeah, we can also solve this by using one while loop or one for loop, right? So this is our optimized approach. So like it will only, so this is our optimized approach, so it will only use one while loop. So yeah, let's look what does this approach says. So we have to use slow fast pointer here. And what is this step one? So this step one is take two pointers slow and fast. So yeah, we will take two pointers slow and fast. They will be initially initialized with head. They will be initially, okay, so they will be initially pointing to head. So slow will be pointing to head and fast will be also pointing to head. Okay, so what is the second step? So the second step says that move slow ahead by one step and move fast ahead by two steps, right? So we have to move our slow pointer by one step and fast pointer by two steps, right? So this is the step, and what is the third step? So now look at the example how we can solve this, okay, so now let us look at the example how we can use this slow fast pointer to find the middle of the linked list, right? So let's say at the very first, slow will be pointing to my head, so slow is pointing to head, and fast is also pointing to head, right? So fast is also pointing to head. So what does our step says that we have to make our slow pointer ahead by 1 only. So slow is pointing to 1 here, so slow will be pointing to 2 after one step. So slow will be pointing to 2. Now how many steps will my fast pointer will take? So my fast pointer will take 2 steps, right? So it will directly jump from 1 to 3. So fast will come up on 3. Now again we have to do the same thing. So slow will come up at 3. So slow comes up at 3, and at which my fast pointer will jump from 3 to 5. So fast comes up on 5, right? So now, is there any element next to 5? So as we can see that there is no element next to 5, right? So yeah, we can say that if fast next becomes null, it means that I have exhausted my linked list. So at whichever node my slow pointer will be pointing, so that will be my middle of the linked list, right? So this is the example this is the example of the odd length linked list, right? So let us find out what is the scenario when length of our linked list is even. Okay, so as we can see that here we have total number of nodes equals to 6. So it is even number of nodes, right? So what were the steps? So slow will be pointing to the first node, that is head. So slow will be pointing to 1. Also fast will be pointing to 1. Now, so slow will move ahead by 1. So slow comes up on 2. So slow will move ahead by 1. And fast will also move ahead by 2. So fast comes up on 3. It will directly jump from 1 to 3, right? Now again slow will come up on 3. So slow comes up on 3. Which position our fast will move? So fast will move 2 points, 2 steps. So it will come up on 5. So fast comes up on 5, right? Now again we can say that now slow will move ahead by 1. So slow comes up on 4. And where does our fast will go? So fast will come up on null. So fast comes up on null. Okay, so as we can see that in odd case, so what can be the condition to break my while loop? So if fast next becomes null, then we can break our while loop. So in what about the even case? So when our fast becomes null, then we have to break from our while loop, right? So these are the two conditions that we have to keep the track. So these are the two conditions that we have to check. And yeah, so let us try to implement this problem. Okay, so as we can see that we will be taking 2 pointers that are fast and slow, and initially they are pointing to head. And at line 46 we node star fast equals to head, and line 47 we have node star slow equals to head. Okay, now at line 48 what were the cases? Okay, so now at line 48, so what is the first condition? Though the first condition is fast not equals to null. So this condition will, okay, so this is the condition for the even length linked list, right? So when my fast becomes null, it means that I have exhausted all my linked list, then just break out from my while loop. And also I have to take one another condition also, like what fast next. Also I have to take the care of fast next also, because in odd case my fast next is the breaking condition from my while loop. So I am taking while fast not equals to null, and then fast connects not equals to null, then I am running my while loop. So what are we doing at line 50? So we are just increasing our slow pointer by 1 point, or like 1 step. And at line 51 we are just making our fast pointer ahead by 2 steps, right? So that's why we are doing fast equals to fast next next, and slow equals to slow next next. So after this while loop is finished, our slow pointer will be pointing to our middle node, middle of the linked list, right? So in the end we can just simply return slow's data. Okay, so let us try to compile and run this. Okay, so yeah, it's passing on the sample test cases. Now let us try to submit this. Okay, so yeah, my problem is solved successfully. And talking about the time complexity here, So the time complexity would be big O of n, right? Because we are only running one while loop and we are processing all the nodes. So time complexity is big O of n. So this okay. So I hope you got this problem's solution. Thank you.